Good morning, my dear friends. Welcome to another video of thematic lectures. Today, I'm going to discuss a new paper in Edexcel Pearson AS level mathematics M1 paper, that is mechanics. So that is about January 2021 question paper. It is actually open, but I don't know whether it is accessible or not in the website. But of course, I'm going to discuss its workings and also the marking patterns of this question paper. And if you want, I can send you the link for Google Drive. You can download the question paper as well as the marked answer script of the same. Okay, so shall we move to the first question? So this first question is purely about a one-dimensional motion. Let's see the question. A small stone is projected vertically upwards with 20 meters per second from a point which is 5 meters above horizontal ground. The stone is modeled as a particle moving freely under gravity. So this question has two parts. The first part is the speed of the stone. We want to find the speed of the stone at the instant when it is 2 meters above the ground. So that is our question. Then the second question is to find the time. Okay, so we will go to the question after finding the answer for A part. So before doing this question, we need to draw a representative diagram or a schematic diagram to understand this question clearly. So shall we draw that schematic diagram? Yes. Well, a stone is projected vertically upwards with a speed of 20 meters per second from a point O, which is 5 meters above the horizontal ground. See that? We have to mark the keywords. So let's see. So this is our horizontal ground. So this is our horizontal ground. And I just marked it as, to easily understand this as our ground. Well, then there is a point O. So this point O is actually what? It's actually 5 meters above the ground. Now the particle is projected upwards. So what happens? The particle will go like this. It reaches to a maximum height. Then what happens? It will falls down. Correct? So it will come to the ground. Am I correct? So now, first question is to find the velocity, the speed at a point which is 2 meters above the ground. And from our common sense, it is very clear that that point will not be above O, because O itself is 5 meters above ground, correct? So somewhere here is our, our required point, such that this satisfies our condition. This point is 2 meters above the ground. Am I correct? Are you able to correlate? Right. Okay, well, so we want to find, so we'll mark this point as letter P. You can mark with any point, that's your discretion. Okay, so I just want to find the, the velocity, or the speed of this particle at this point B. Let that speed be represented by VB. And the velocity with which, or the speed with which the particle is projecting from O. So that is upward, correct? So that is marked with the letter B, VU. Okay, you can mark or VO, VO. Okay, and we know that this is projecting upwards. That means the particle is moving against gravity. Therefore, the acceleration with which this particle is moving is minus 9.8. Why it is minus 9.8? Because the particle is, moving against the gravity. Minus 9.8 meter per second square. Well, how to find the speed at the point B? Well, let's see. So can you please tell me what is the displacement of this particle? What is the displacement of this particle? So displacement of the particle means that is actually the net displacement happened for this, the particle. Am I correct? So we are going to use one of the equations for solving the answer for A part. So we have three equations. So here I'm going to use V square is equal to U square plus 2AS. V square is equal to U square plus 2AS. So what is V? V is the final speed. And what is U? U is the initial speed. And acceleration due to gravity, as well as S is actually the, the net displacement. So in our case, S is actually what? S is actually minus 3. What is the reason for that, my dear? My dear students, why it is S is minus 3? You can see that the displacement is actually, since the particle is moving upward, now what happened? This point, B is actually below the point O. So that means what is that net displacement? You can see that net displacement is actually what? It is actually minus 3. Why it is minus 3? Because finally the particle displaced downwards. Correct? So S is equal to minus 3. S is equal to minus 3. And acceleration due to gravity is minus 9.8 meter per second square. And initial velocity, that is our initial speed, that is VO. And it is already given in our question that it is 20 meter per second. Therefore, V, that is the final speed at the point B, that is a big question mark. So VB square is equal to 20 square plus 2 times minus 9.8 times, this is minus 3, like that. This is minus 3. So substitute VB square is equal to 20 square plus 2 times minus 9.8 times minus 3. And if you're working this answer, so you just input these values in your calculator, so you will get definitely the answer. So what is the value of VB? You will get. So substitute this value, because VB is actually the square root of 20 square plus 2 times, because minus and minus got positive, times plus 3. And that value is 21.4 meter per second. If you're rounding to 3 significant figures, or if you're rounding to 1 decimal place. Well, I hope you got it. So that is the answer for A part. Okay, 21.4 meter per second. Okay, Mono, next question. So be part of this question. The total time between the instant when the stone is projected from O and the instant when it first strikes the ground. So we are going to, once again redraw that figure. It's not actually needed, but for, getting a clear idea, this is our point O and this is our ground, correct? And this point is O itself, it is 5 meters above the ground. Now what happens? Once it's projected, the particle will go like this. It reaches to a maximum height. It attains a maximum height. And then what happens? This particle will returns to the ground. And what the examiner is asking exactly, they're asking to find the time. Okay, so time of flight. So I just want to find the time it takes to reach to the ground. Okay, so well, once it reaches to the ground, this ground is actually below from the projecting point. So the displacement is equal to S is equal to -5 because it's already attained when it reach to ground, right? Sorry, S is equal to -5 meter. And what is acceleration due to gravity? That is minus 9.8 meter per second square. Then you might be thinking, sir, actually why it is minus 9.8 meter per second square? Why it is not positive? Like, after some time, this particle is coming downwards and it is now in the same direction of the gravity. But actually we are looking the conditions of this particle when it is initially projected. Initially, the particle is projecting upwards. So we are just considering the conditions of initial projection. So in initial projection, the particle is moving upwards. So that is obviously against the gravity, minus 9.8 meter per second square. And now the t is actually the time taken. Then what is the initial velocity? That is VO, right? That is U, and that is 20 meter per second. So we are now in a position to find the value of t, right? So we have a kinematic equation. What is that? S is equal to ut plus half at square. Did you remember? There is a formula, right? Ut plus half at square. So S is what? That is -5 is equal to 20 times t. Unfortunately, t is not known, plus half times minus 9.8 times t square, because a is minus 9.8. Yes, now it becomes a beautiful quadratic equation. You will get two values of t. Am I correct, my dear students? So -5 is equal to 20t. My half times minus, that is minus 4.9 t square. And if you're writing this as a beautiful quadratic equation in the form of ax square plus bx plus c is equal to 0, that means 4.9 t square minus 20t minus 5, because I'm bringing all the terms to one side. So in this case, I'm bringing these two terms from the right hand side to left hand side. It becomes 4.9 t square minus 20t minus 5 is equal to 0. So please input this value in your calculator, and definitely you will get two values of t. So could you please calculate what are the two values of this? I'm also parallelly working this value. So substitute these values. So if you want to take a pause of this video and you try to input these values, and then you please find yourself the answer. And I'm getting one of the values as 4.317, and another value I'm getting it as minus 0.236. Time is in seconds, right? This is seconds. This don't read it as 5, it is seconds. Okay, and we know that time never becomes negative. Time is a scalar quantity, right? So negative is not possible. So only one favorable answer we have, right? So if you're rounding to 3 significant figures, the time is 4.32 seconds. So what is the meaning of this answer? It means that in 4.32 seconds, this particle will reach to the ground. Okay, so what is the answer for this part? That is 4.32 seconds. Hope you got it. Well, any questions? So if you have any questions, please drop a comment below this video. Okay, so shall we move to question 2? So in this question 2, we just read this question. in question 2, this is a question falls under the category of momentum conservation. Two particles, P and Q, have masses 2m and m respectively. The particles are moving towards each other in opposite directions along the same straight line on a smooth horizontal plane. The particles collide directly. Immediately before the collision, the speed of P is 3u and the speed of Q is 2u. The magnitude of the impulse exerted on Q by P in the collision is 5 mu. So similar to part 1 question, similar to first question, this question also has 2 parts. First question is about finding the speed P immediately after the collision. Then in second part, the speed of Q immediately after the collision. Well, as I said in the previous question, here also we are going to draw a schematic sketch, a rough sketch of the idea or the data that is given in our question. Based on the data given in our question, we are going to draw a schematic sketch. As we read, we have 2 particles. So these 2 particles are, marked with, P, and this is Q. Now, these 2 particles are approaching from the opposite direction. So we can mark it as, this P is marked initially approaching with a initial speed of 3u, and Q is approaching with the initial speed of 2u. Initial speed of 2u. Now what happens? It collides. It collided. Right? It collided. During this collision, what happens? This P will exert a force on Q. Similarly, Q will also exert a force on P. That is action-reaction pair, according to Newton's third law. Every body equal under opposite reaction. So due to this action-reaction pair, what happens? The respective momentums of this particle P as well as Q changes, and that is known as nothing but impulse. So what is impulse? I would like to review what is the concept of impulse. Impulse is change in linear momentum. Impulse is change in momentum. So what is change in momentum? Final momentum minus initial momentum. That is how we are finding the change in momentum. Okay. Well, so we are going to proceed with this idea. So during this action, what happens? After collision, this particle is getting an impulse. The particle P is getting an impulse. And similarly, the particle Q is also having the same impulse because this is a same system. Correct? So impulse available for Q from P is exactly equal to impulse available for P from Q. So that impulse is given according to our question, that is 5 mu. And after this collision, what happens? The particle will move in the respective direction. Okay. So since we just assume in the after the collision also, I'm just assuming both are moving in the same direction. V and VW are the final speed after this collision. Okay, I hope this concept is clear. I hope this concept is clear. Okay, we'll proceed. Well, move back to the question. Find the speed of P immediately after the collision. So that means we are in a position to find what is the value of V. How we will find? We'll use the basic equation of impulse. So we can say that we can separately calculate for P as well as for Q. So what is the impulse? What is the impulse? See, we can read this question once again. The magnitude of the impulse exerted on Q by P in the collision is 5 MU, right? So therefore, the magnitude of the impulse exerted on P by Q is also what? That is also same, but in the opposite direction, correct? According to this direction. So horizontally moving right, we can take it as positive. Moving left horizontally, that we can write it as, the negative. Okay. Okay. So impulse is change in momentum, as I said earlier. So impulse is equal to change in momentum. So I'm just considering the case of P first. Since this is moving in the opposite direction, impulse is purely a vector quantity. Therefore, it is moving in the opposite direction. So I can keep here it is minus 5 MV. That is equal to change in momentum, right? It's not change in M, it's actually change in P, right? So P is actually the momentum. So what is the final momentum? What is the final momentum? The final momentum is, initially it is moving with the same, right? 3U and B. So M times, what is the mass basically? What is the mass of this particle P? P is having a mass of 2M, right? I didn't mark that. It's 2M and M. So 2M times B, that is final momentum, minus 2M times its initial velocity was 3U. Correct, my dear students? 3 times. Now, minus 5 MU is equal to 2 MV plus 6 MU. I mean, it is minus, my bad. 2 MV minus 6 MU. And if you're bringing this to the side, what happens? It becomes, okay, I'll write here. Minus 5 MU plus 6 MU is 2 MV. So MV is equal to 2 MV, MU. I got confused with the U and V. So it is MU is equal to 2 LV. M got cancelled. U is equal to 2V, or V is equal to U over 2, and that is what? It's 0.5 U. So 0.5 U is the velocity of the particle, velocity of the particle. Whose particle? This particle P after this collision. Now, so that serves the answer for A part. So what is the answer for A part? That is V is equal to 0.5 U. Then we'll move to the B part. That is about Q, the particle Q. And we know from this figure, it's collided and it gets an impulse. That is 5 mu, correct? The particle is moving forward. So impulse is equal to change in momentum, right? And what is change in momentum? Final momentum minus initial momentum. So what is the mass? Mass is m, right? And it is w because we assumed it as w, right? So m times w minus m times, we know that initially we can see this figure. Initially, the particle is moving in the direction towards left side. That is very important. Okay, so m times w minus m times this multiplication, okay, minus 2e. So what happens, my dear students? This minus and minus got become positive. So 5 mu is equal to mw plus 2 mu. So you can bring this 2 mu to this side. So 5 mu minus 2 mu is mw. That is 3 mu is equal to mw. M got cancelled. So what is our answer for w? W is 3u. So answer for w is going to be 3u. So this is one of the methods. This is one of the methods. Otherwise, using the answer A, we can use another property, that is, according to principle of conservation of momentum, momentum before conservation and after conservation. I mean, momentum before collision is actually equal to momentum after collision. You can use that as well. CLW, conservation of linear momentum. Okay, so W is equal to 3u. Did we get it? Can I move to the next question? So we did 2 questions. Well, go to third question. Wow. In this question, it is actually a conglomeration of friction and the concept of motion due to this force. Anyway, we'll read this question. Parcel of mass 20 kilogram is at rest on a rough horizontal floor. The coefficient of friction between the parcel and the floor is 0.3. That is our mu. 2 forces both are acting in the same vertical plane. That is very important because it's purely a 2-dimensional question. Of magnitude 200 Newton and T are applied to the parcel. The line of action of the 200 Newton makes an angle of 15 degree with the horizontal, and the line of action of T makes an angle of 25 degree with the horizontal. The parcel is modeled as a particle P. Find the smallest value of T for which T remains in equilibrium. So here, drawing a free body diagram will really help us. How? So here the particle P is our particle P. What is free body diagram, my dear students? It is actually a diagram in which we will remove all the supports, and in this diagram we will keep all the forces acting on this particle. Definitely this particle as a mass, and due to that, the weight is acting downwards. And similarly, there is a reaction. Due to this weight, there is a reaction because it's sitting on the floor or resting on the floor. And apart from that, there is two forces. What are they? One is tension, and one is this beautiful 200 Newton. Correct? 200 Newton and T. Now, here you can see that W and R are exactly acting in the vertical direction. But unfortunately, 200 or T neither acts in vertical or in horizontal. Then what we will do? Yes, we forgot to mark the direction, the angle of this T and 200 Newton, right? So this is what, my dear students, this is 25 degree, correct? And what is this angle? Is that 15 degree? Is that 15 degree? Yes, it is. Now we are going to resolve this T and 200. Okay, so how we will resolve? The two components of T are one is acting like this. This is what T cos 25 degree. And what is this? This is T sine 25 degree, correct? And similarly, what is the resolved components of 200? Similar, right? It is 200 sine 15 degree, and then here it is 200 cos 15. So due to the concept of resolving, we can simply remove this part. Which part? Because we already marked or we considered the effect of this, right? And now we resolve this part. Okay, well, now what is remind? What is remind? Yes, we forgot to mark the friction. We just assume that T is greater, or we just assume this particle is moving in the direction of T cos 25 degree. T cos 25 degree. So here, since the particle is trying to move in the direction of T cos 25 degree, cos 25 degree, this will move towards right, correct? This will move towards right. Or we can assume, or you can use, you can assume this is moving in the 200 cos 15 degree. In that case, the net moment we just assume, either way is fine. Okay, either you can assume in this direction the particle is moving, or in this direction. Okay, due to this horizontal force. So whatever be the case, like if you're assuming this particle is moving in this direction, definitely the particle experiences a friction. And we know that the friction is always opposing the motion, right? And we can mark it as R. R means, what is R? R is nothing but, or you can mark it as, to avoid the confusion, we have already marked one R. So we can mark it as F. F as friction. Well, Now the things are become very easy. Why? Why? Because we can resolve, or we can write two equations based on this free body diagram. How? Net force on the horizontal direction is equal to mass times acceleration. Similarly, net force on the vertical direction is equal to mass times acceleration acceleration in vertical direction. This is acceleration in the horizontal direction. And interestingly, though these two forces are acting, once again read this question. This is in equilibrium. So we are now in a position to find the minimum value of P for which P remains in equilibrium. What is the meaning of equilibrium? Equilibrium means the particle is not in motion, or the particle is not having acceleration in both directions. So indirectly, it means that it is equal to 0. Then we will write equation in the horizontal part, horizontal direction. So we are just assuming this particle is moving in this direction. So this force, we will keep it as positive. So it is acting in the left side. Don't confuse with the sign convention of left and right. So here the particle, we just assumed it is moving in 200 cos 15 degrees. So we assume that as positive. So 200 cos 45 degree minus T cos 25 degree minus F, that is equal to 0. So that is the equilibrium equation for the horizontal part. Then my question, what is F? F is nothing but friction, we know, right? But how we will find that friction? So F is equal to what? The coefficient of times normal reaction. So what is normal reaction? That is represented with a R in our case. Then what is R? See, this is normal reaction and this is weight. So what is the cause of this normal reaction? Because the weight is acting, right? So weight is equal to what? Mg. So R is exactly equal to mg. So what is mass? Mass of this particle, once again, we will go to the question. What is mass? 20 kilogram. And G is acceleration due to gravity. So 20 times 9.8. So this is my value of R. Therefore, what is my friction? Mu. Mu is given as, in our question, it is given as 0.3. Am I right? So F is equal to 0.3 according to our question. The coefficient of friction is 0.3. So force of friction is 0.3 times 20 times 9.8. I hope you got it. So F is equal to 0.3 times 20 times 9.8. Well. Now things are becomes easier, right? So we figured out the value of F. Now we will plug this values 200 cos 25 degree minus T. Oh, it's 15 degree, right? It's not cos 45, my bad. While writing or copying, I missed that 15. It is actually cos 15 degree. So it is 200 cos 15 minus T cos 25 minus 0.3 times 20 times 9.8, and that is equal to 0. So could you please simplify this? please simplify this. 200 cos 15 minus 0.3 times 20 times 9.8, 134.4, rounding to 1 decimal place, minus t cos 25 is equal to 0. So from this, we can calculate the value of t. So please plug these values and find the answer, because they are asking what? Find the smallest value of t for which p remains in equilibrium. So please figure out this value. So t cos 25 is 134.4. So t is equal to 134.4 divided by cos 25. So please plug these values. 134 divided by cos 25. I think, I made a small silly mistake here while calculating the value of r. Why? Can you please once again go to that question in the free body diagram? Because I missed, two components. What are they? 200 sine 15 and t sine 25 also acting in the upward direction. So I really missed that. Apology for that. We didn't consider that two vertical components. So we will rework on the value of r. Okay. We will rework on the value of r, because in this we missed two more vertical components. What are they? T sine 15, and another is 200 cos 25. 200 cos 25, correct? 200, I means, so that is 15 degree, right? This is 25 degree and 15 degree. So I missed that part. This is what, my dear students? This is 200 sine 15 degree. This is what? T sine 25 degree. Well, so we can write the equilibrium equation in the horizontal vertical direction. So here you can see the weight is being balanced. R is acting in the upward direction, plus 200 sine 15 degree plus t sine 25 minus W is mass times acceleration in the vertical direction. Since the particle is in equilibrium, this part becomes 0. So don't confuse, okay? Because why we are not, it's directly taking W as R, because we have two more components. So I will bring all this stuff together for a while. We'll delete this part. Just drop off these things. So R plus 200 sine 15 degree plus T sine 25 minus W is equal to 0. So R is unknown. Unfortunately, we don't know the value of R. And 200 sine 25. Sine 15, I mean. Plus T sine 25 minus, this is mass times acceleration due to gravity. Mass is 20. and G is 9.8, and that is equal to 0. So we can make an equation in terms of R and T. So R plus T sine 25 is equal to 20 multiplied by 9.8 minus 200 sine 15 degree. So please plug these values. 20 multiplied by 9.8 minus 200 times sine 15. I think 144.2. So R plus T sine 25 is 144.2. So this is one of the equations of simultaneous equation. So this is one equation. And then we'll consider once again the horizontal part. In this horizontal part, this is particle P. Here this T cos 25 is acting in this fashion. Here 200 cos 15 is acting in this fashion. And we just assume 200 cos 15 is the direction in which the particle is moving horizontally. So in that case, the friction is opposite to the motion, and friction is equal to what? Mu times normal reaction. That means mu times R, correct? So I will add one more page here. So 200 cos 15 degree minus T cos 25 minus 0.3 times R, because normal reaction is unknown, right? And that is equal to mass times acceleration in the horizontal direction. Since the particle is in equilibrium, this value is equal to 0. Well, 200 cos 15 degree minus T cos 25 minus 0.3 R is equal to 0. That means another equation we got. What is that equation? Cos 2T cos 25 plus 0.3 R is equal to 200 cos 15 degree. So this is my second simultaneous. So solve these two simultaneous equations and we'll find the value of T and R. What are the two simultaneous equations? One is this equation, right? T R plus T sine 25. R plus T sine 25 is equal to 144.2. The second equation is 0.3 R plus T cos 25 is equal to 200 cos 15 degree. So directly you can input this value in a calculator. Solve this. Please figure it out. So what is your answer? So I am also inputting these values. So R value will get it as 62.9, and T value will get as 192.3. So what is the minimum value of T? Because T is for our point of interest. T value we get it as 192.3 Newton. I hope you got it. Any questions? So we have to solve these two simultaneous equations. So how this mark distribution for this question, how this examiner is looking this question. So altogether 9 marks. So what is the split up for this question? Split up. And if you first of all, if you are writing, the equation for the horizontal direction and vertical direction, you will get 2 and 2 marks to each for this. Okay, 2 and 2. Then for solving altogether, you will get 5 marks. So 2, 2, and 5. So altogether 9 marks. Okay, go on. Next question. Question number 4. So please read this question.